So in this section, I want to show you how to create the unit circle that most people talk about to find all the different values of trig functions, and then we'll actually evaluate some trig functions using our created unit circle. So there's actually a template in the supplemental files that you could use. I'm just going to draw it from scratch here. So this is section 6.2, and it's called the unit circle. Now it's called the unit because the radius is 1. So I'll draw this from scratch here. X and Y axis. And here's our circle. Now the radius is 1, which means that this point right here, a quadrantal angle, this point has the coordinates 0, 1. This is 90 degrees. And if you convert it to radians, 90 degrees is the same thing as pi over 2. This is 0 degrees, or 0 radians. If this point is 1 unit away from the origin, it has the coordinates 1, 0. 180 degrees is over here. Now if 90 is pi over 2, we're going another pi over 2 from 90. So pi over 2 plus pi over 2 is 2 pi over 2, or pi radians, which has the coordinates right here at -1, 0. And then going a little bit lower, so we have pi over 2 is 90, 2 pi over 2 is 180, 3 pi over 2 is 270, and this has the coordinates 0, -1. And then we're back at the origin, so 3 pi over 2 goes to 4 pi over 2, or 2 pi. So that takes care of our quadrantal angles. Let's draw 45-degree angles. I'm just going to draw a line through here. That represents 45-degree angles, and I'm going to do the same thing going this direction. So if that's a 45-degree angle, this is 45 degrees, or, well, if pi over 2 is 90, half of that is pi over 4, which is 45 degrees. Now, if 45 degrees is pi over 4, 2 pi over 4 is 90 degrees, or pi over 2. 3 pi over 4 . 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and that's how we go by increments of 45 degrees. Let's go up by increments of 30, which will also give us increments of 60 along the way. So we'll do this in green. I'm just going to draw a 30-degree line. Like here. I'll draw another 30-degree line right here. Draw another 30-degree line. I'll draw another 30-degree line. And I think we have all 30-degree increments. Now this will be 30 degrees. Now 30 degrees, if 90 degrees is pi over 2, if we divide that by 3, we'll get 30 degrees. So this is pi over 6. Now we're going to go up by increments of pi over 6. Every 30 degrees is another pi over 6. So we have pi over 6. We have 2 pi over 6. We have 3 pi over 6. We have 4 pi over 6. We have 5 pi over 6. Six pi over 6. 7 pi over 6. We have 8 pi over 6. We have 9 pi over 6, 10 pi over 6, and we have 11 pi over 6. And then we have 12 pi over 6, which is 2 pi. All right, so now we have all of our angles in degrees and radians. So now let's start filling it in. When we fill in the unit circle, we're going to use our special triangles and quadrantal angles that we've talked about. So we have 2 special triangles, and we have the quadrantal angles that we've talked about. And quadrantal, I think we already have. The special triangles are 45, 45, 90, 30, 60, 90. Remember, the smallest side is always 1, and you need to remember the ratios for the other sides. So remember, along our unit circle, we said that y was equal to the sine of that angle, x was equal to the cosine of that angle, and y over x was equal to the tangent of that angle. So what we're going to do is we'll go through each of these angles and we will label what the coordinates would be. The x value is going to be the cosine and the y value is going to be the sine. Alright, so 30 degrees, I'm looking at my 30-degree triangle right here, and the x value, the cosine, would be root 3 over 2. The sine of 30 degrees is 1 over 2. Now one thing that I could do is I could actually transfer that onto the other side of that line, because this is the same 30 degrees, it's the same 30-degree reference angle, but we're going left and down, so both of those would have to be negative. So that takes care of that. Let's go to the next angle, 45 degrees. Now, when we have 45 degrees, I'm looking at my triangle, sine and cosine would both be 1 over root 2. Rationalized would be root 2 over 2. And if we reflect over this line, the x and y values would both be negative. So negative root 2 over 2 and negative root 2 over 2. We could actually do the same thing with this angle. This reference angle is also 45. So I'm going to label this angle positive root 2 over 2 because it's a positive x value and a negative y value. And I'll do the same thing over here. This would be a negative root 2 over 2 because our x value is going to the left. The y value is positive. We'll actually fill in for the 30-degree reference angles as well. So this is 30 degrees, this is 30 degrees, this is 30 degrees, and this is 30 degrees. So I'll fill in for those. The 30-degree angles are going to have root 3 over 2 for cosine and 1/2 for sine. But remember, anytime we go left, it's negative. And anytime you go down, it's negative. Okay, and it looks like I have all the 30-degree angles taken care of. So now we just have to do the 60-degree angles. Looking at my 60-degree angle right here, looks like the cosine would be 1/2. Cosine's the x value. And the y value would be √3/2. Now I'm going to do the same thing for all of my other angles that have a reference angle of 60 degrees. Alright, so this, we're going left, so that's -1/2, comma √3/2. This angle right here, we're going left and down. And then this angle right here, we're going down. And that's how you complete a unit circle. We use reference angles of 45, 30, and 60, and we also use our quadrantal angles. So this is pretty cool. I mean, once you have it created, let's look at 330 degrees right here. What's the cosine of 330? √3/2. I mean, that's pretty quick. What I prefer people do is they actually draw the special triangles and figure it out that way. I'm not a huge fan of memorizing, but you could see from the unit circle it's pretty easy to look and get your values. Like what would be the cosine of 3π/4? Well, cosine's the x value. Now in some high schools, teachers provide the unit circle and the students just kind of pick these out. What about if I asked you what's the secant of 30 degrees? Well, secant's the reciprocal of cosine, so you would just take the reciprocal of √3/2. So what I wanted to do to finish up this section is let's just go through some examples, and we'll evaluate those angles using the unit circle. One thing I just wanted to point out here is if you look, you can see a pattern, right? So we have √3/2, √2/2, 1/√2. And then that's the same kind of pattern if you go this way. It's reversed if you go this way, and it's kind of reversed if you go this way. Some people memorize patterns, some people memorize the whole thing. I prefer you don't memorize like anything. I prefer you just kind of do it by hand, but it's not a big deal. So let's go ahead and we'll do some examples. We'll say evaluate the following. Okay, let's find the sine of 3π/2. Well, 3π/2 puts us right over here. Sine, remember, is the y value, so clearly that's -1. The cosine of 3π/2 is the x value, which is 0. And the tangent of 3π/2 would be the y value over the x value, which is undefined. So it doesn't get much faster than that. What if I asked you to find the cosine of 5π/3? Now remember, π/3 is 60, so 5 times 60 would be 300, which is right here. What's the cosine there? The cosine's 1/2. Cosine, remember, is the x value. What about the cotangent of 5π/6? Now π/6 is 30 degrees, so 30 degrees times 5 is 150, which puts us over here. So the cotangent is the reciprocal of tangent. So this one could get a little tricky. Tangent, remember, is the y over the x value. So we would have 1/2 divided by -√3/2. That would be the tangent. Cotangent would be the x value divided by the y value. So let's see if we could figure these out here. If I asked you the cotangent, that would be negative root 3 over 2 times 2 over 1, which is just negative root 3. And if I asked you what's the tangent, that would be 1/2 times 2 over negative root 3, which we could rationalize and just get negative root 3 over 3. That's how we figure that out. What about if I asked you for the tangent of negative 7 pi over 4? Now, let's see if we could figure this out just by using the unit circle before we even convert to degrees. Pi over 4, remember, was 45 degrees. So we're going to go 7 times around in the negative direction. This would be once, twice, or let me see here. Once, twice, 3 times, 4 times, 5 times, 6 times, 7 times. So negative 7 pi over 4 would put us right here. All right, so that's negative 7 pi over 4, which is actually negative 315 degrees, but we didn't even have to convert that. We just went 7 45-degree increments around. Now the tangent at this point would be the y value divided by the x value. Well, we're dividing the same thing by itself. The tangent here would just be 1. All right, a couple more. What if I asked you for the sine of negative 5 pi over 6? All right, so let me clear this out here, trying not to erase anything. Okay, so pi over 6, if you remember, is 30 degrees. So we're going to be going 5 30-degree increments in the negative direction. So this would be 1, 2, 3, 4, 5. So negative 5 pi over 6 does put us right there on the 210 degrees. This is actually negative 150 degrees, but it doesn't matter. We went 5 increments of 30 in the negative direction, and we wound up right here. So what's the sine of that point? Well, the sine is clearly negative 1/2. It's pretty quick. We're just going up by pi over 6 increments. Let me erase these. Hope I don't clear off any of my lines. All right, and we have one more. What if I asked you for the cosecant of 13 pi over 3? Okay, so it's positive, and we're going to go 13 increments of pi over 3. Now, pi over 3 is 60 degrees. 60 degrees times 13 is 780. But we're going to go every 60 degrees. All right, so let's see if we can figure this out. We'll go 1 plus 60, 2, 3, 4, 5. We're pretty much skipping 130 degrees, right? So we're skipping a 30 and then the next one. So it's every other 30 degrees. So we're up to 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 puts us right here. And if we want to find the cosecant of that value, what we want to do is take the sine and just do the reciprocal of it. So we're going to do 1 over the sine value, root 3 over 2, which is 2 over root 3. And rationalizing, gives us 2 root 3 over 3. So I hope that makes sense. I hope you understand the unit circle a little bit better. Stay tuned for our next section.